All right, let's get right into it. We hear so much about 5G, but there's this one killer feature, kind of hiding in plain sight, that could totally reshape our digital lives. Today, we are breaking down its secret weapon, network slicing.
So picture this, right? You're on a super important video call, you're in the final moments of an online game, or you're just trying to stream a movie. And boom, everything just freezes up. It's that universal feeling of frustration. And believe it or not, it happens for a very specific reason.
You see, for decades, our mobile networks have basically treated all data the same. It doesn't matter if it's a text message or a 4K video stream, everything you do online has been crammed into the same giant shared pipeline, all fighting for the same space. But 5G, it was built from the ground up to finally fix that fundamental problem.
Now, to really get why the solution is so cool, we have to understand the problem a little better. Let's call it the Great Network Traffic Jam. And this really hits the nail on the head. For the longest time, networks just offered one data pipe for everything and everyone. They just weren't built to know the difference between, say, a critical medical alert from a hospital and a funny cat video. It all just got chucked into the same pile. And this slide just lays it out perfectly. Back in the day, our needs were pretty simple, right? Calls, texts, maybe some basic web browsing. But today, oh man, we have intense online gaming that needs zero lag, 4K streaming that eats up bandwidth, the wild idea of remote surgery that needs rock-solid reliability, and they're all duking it out for the exact same network resources. That one-size-fits-all approach, it just can't keep up.
So how does 5G fix this massive traffic jam? Well, it does it by turning that single, crowded road into a multi-lane superhighway for data. Let's dig into how that actually works. Okay, this right here is the big idea. Instead of having one physical network that does one job, network slicing lets operators create tons of separate virtual networks. Think of them as custom-built networks. Each one is totally independent and tailored for a specific job, but they're all running on the very same physical towers and cables. And this is just a perfect way to visualize it. You can literally see these different parallel networks. You've got one slice just for public safety, for first responders, that has to be incredibly reliable. Then there's another for big companies, and a third that's perfectly tuned for streaming high-quality video. Each one is its own protected, dedicated lane.
So, here's the bottom line. Your 4K movie stream is no longer stuck in traffic behind an ambulance's critical data feed. Each one gets its own custom-built lane on this data superhighway. That means they get the exact performance and reliability they need without ever slowing each other down. It's a total game changer.
Now, this isn't some kind of magic. It's all built on very specific, standardized technology. So how do you actually build one of these custom lanes or slices?
It pretty much boils down to a simple three-step recipe. First, you figure out exactly what the slice needs to do. Is it all about super low lag, massive bandwidth, or just being unbelievably reliable? Second, you configure all the parts of the network to deliver on that promise. And finally, you decide exactly which users or devices get to use that special slice.
And this isn't some brand new, untested idea. The global standards body that governs all this stuff, the 3GPP, has been working on network slicing for years. It was a core part of 5G right from the very beginning, and it's just been getting smarter and more powerful with every single update. This is a mature, well-thought-out technology.
All right, enough of the theory. Let's talk about what this stuff can actually do in the real world. This is where it gets really exciting.
First off, we're talking about a massive economic opportunity here, something like $200 billion. And as you can see, this potential is spread out across all kinds of critical industries. Healthcare, government, transportation, they're all leading the charge because they have these unique problems that, well, network slicing is perfectly built to solve.
So, let's take a hospital, for example. They could set up their own private virtual network slice that is used only for their most critical devices, like patient monitors. This slice is completely walled off and guaranteed to work, no matter what. Even if there's a huge concert or a sports game right outside causing massive public network congestion, the hospital's critical gear just keeps working perfectly.
Or think about the cool gadgets we're all waiting for, like AR glasses. To feel real, those things need a crazy amount of data, delivered with practically zero delay. With network slicing, those glasses can get their own dedicated low-latency slice, guaranteeing that smooth, immersive experience that's been promised for so long. No more lag. And get this, it's even more flexible than that. Imagine you're about to hop into a serious online gaming tournament. You could actually pay a tiny fee to temporarily put your connection on a premium, low-lag gaming slice for just the next couple of hours. It gives you a real competitive edge. These slices can be created and taken down whenever you need them. Okay, so the tech is here, the possibilities are huge. What's the final piece of the puzzle? How do we actually get these incredible custom networks working on our devices?
Well, there are two main ways this is rolling out. The first one, which works right now, is based on your subscription. A special device, like those AR glasses we talked about, is just permanently tied to one specific slice. Simple. But the really cool future is application-based slicing. That's where your smartphone will be smart enough to send your game traffic to the gaming slice and your video streaming app to the video slice, all happening automatically in the background. Now that's a bit more complex and needs the phone's operating system to be on board.
So for this whole thing to work, you really need three key pillars to be in place. It's like a three-legged stool. First, the cell tower itself needs to be smart enough to handle slices. Second, the brain of the network has to be able to manage them all. And finally, the phone or device in your hand has to know how to ask for and use the right slice at the right time. It's a complete end-to-end system.
And that really brings us to the final big idea here. Network slicing is what finally moves us from a world where we have to work around the network's limitations to a world where the network actually adapts to whatever we need it to do. So the question isn't, what can the network do for us anymore? It's, what do we want to build with it? If you could design the perfect network for any one task, what would you build?